Welcome, everybody. Good morning, good afternoon, good evening, and thank you for joining to Neo4j Live. This episode, Know Rivalry. So I have two guests today instead of one. So I think it's the first I had in the past. I only had one guest here. So two guests today. It's David Tyler and Joe Cobbs. Welcome to you.
Hello, Alexander. How are you doing?
Good. How are you?
Doing
How
great.
was your
Thank
week?
you. Excited for this.
Yeah, me too. This should be fun. Thank you everybody for joining. Obviously, if you're watching this live, this is gonna be a little bit sports themed. So if you are into sports, maybe let us know what's your favorite team, so we can see and what your favorite sports is. Before we dive into the actual topic, I'd like to take a short detour and make a quick announcement for Notes 2022. The call for papers is open. So Notes is our online developer conference taking place online obviously, but yearly now. So we did the last edition end of 2021, and this year's is coming up. And I want to say that we have the call for papers open. Call for papers is open until the 20th of August. So that's another 2 weeks. So if you are interested in presenting, interested in showcasing anything, and it can be high level topic, it can be very down into the technicalities, anything goes. Basically, please submit. Don't be shy. We'd like to have as diverse as possible lineup. So if you can make it, if you are interested in talking about graphs to a global audience, please submit to that. So that's that. Link is in chat. So if you're wondering, but now let's move on and talk about sports, talk about Know Rivalry. But maybe quickly, Joe and David, maybe you want to introduce yourselves a little bit and tell the audience who you are, what you're doing, and and maybe why sports.
Joe, you want to start us off?
Sure. I'm Joe Cobbs. I'm a professor and department chair at Northern Kentucky University, which is just outside of Cincinnati. And our department is sports business and marketing. And then we also have construction management in our department as well. So diverse disciplines. And I teach a rivalry course here at Northern Kentucky. And Dave and I met when I got my PhD at the University of Massachusetts over 10 years ago now, and started to kind of discuss and birth this project that became Know Rivalry. But before I was in academia, I worked in college athletics, and I also worked for a sponsorship agency in Detroit before that. So I had some different areas of industry experience before going the research and academic route.
Cool.
Okay. And as I mentioned, I'm David Tyler. I'm currently an associate professor at the University of Massachusetts in Amherst, Mass. It's about an hour and a half from Boston. And my main areas of research, obviously, are sport rivalry and also sport data and data analytics. Basically, any excuse I get to play with data, I want to take it.
That sounds good. Yeah, that's very interesting. And what's your favorite type of sport? So, what if somebody says I have 2 tickets to any game, any type, or whatever? What would you say? What should that be?
That's an easy question for me. I would say the Belgian Grand Prix, Formula One.
I see. Yeah.
If anybody is a Formula One fan out there, they know the track is called Spa, and
Spa,
it's a pretty
yes.
famous track. So I'd love to go to that event at some point. I've been to several races around the world, but I've never been to that one.
Yeah, and I wherever there's strong fan engagement, whether the fans are into it, I care much more about what's going on in the seats than on the pitch, or at least I find it more interesting. So whether it's a darts match with 10,000 people in the open, which I still can't believe, or football match or something, just wherever it's a fun environment.
Yeah, I think that is how, I mean, for me, it's the, I agree with you on that. I think it makes more fun if you have an engaging audience, and if that is kind of driving on. So it's whatever is going on the pitch is maybe secondary almost if you have a good crowd. So very cool. And then Know Rivalry. So how did that start, and how did you decide this is something we want to make into a project now, and how did the idea come around?
Yeah. Well, we'll give a quick background of that and a little bit about the research, because that will frame the main topic of discussion, which is talking about the data and how we use it. Very briefly, it came in grad school, where I needed a quick definition of rivalry and realized that one didn't exist. There wasn't consensus. And that's what launched the research idea for me. For Joe, it was a little earlier when he was working, and his boss in marketing, wanted to label everything a rival. Like, we're playing a rival whoever. And Joe found that rather frustrating and inaccurate. But if you don't mind, can I share my screen, and
of course, yes.
I will walk you through a little bit about just some of the few things about the research that we do. One of them is we look to measure fan perceptions of rivalry. So one way we do that is we say, okay, you've got 100 rivalry points. How would you allocate those across the rivals of your favorite team? And so you can give all 100 points to one team. You can give 60 to one, 30, 10, however you feel it's appropriate to allocate those rivalry points. So this person gave all 100 to the Marines. This other person gave 60, 30, 10 to different rivals. Once we have that data, we can start putting together a network of and understanding the rivalry perceptions among fan bases. So in this example, we have University of Michigan, Michigan State University, and Ohio State University, which are three big-time college football programs in the United States. So these are all stadiums that would get 100, sometimes over 100,000 people per game in them. So big sports. But for Michigan State fans, out of 100 points, they allocate an average of 67 to the University of Michigan. So that's their big rival. Michigan kind of sees Michigan State as a rival, but less so. That's the 17 points. For Michigan, their big rival is Ohio State, which is they give 69 points to Ohio State. Ohio State gives even more back, which is the 91 points to Michigan. And then, not very much between these last two. And so from this, we can learn about rivalry, like teams can have more than one rival, their degrees of rivalry, and rivalry is not necessarily symmetrical. It depends on which side you're on. So this is just an example of the kind of questions we're asking and the data we're using. And from that, we can, do other fun things like find, all right, what are the most intense rivalries in a league? What are the most unbalanced, where one side really cares about the rivalry and the other one doesn't. So that was college football. This is baseball examples. And this is information that is on the website, which I got thrown into the chat there. So you can check that out and play with the data there. We'll talk more about that website a little bit later on as we talk about the integration with the database. But that's just a place where we can share our data. We also look at things like what are the antecedents or sparks to the rivalry or ingredients to the rivalry recipe. If we're doing Formula One, this is what one respondent said about the Ferrari McLaren rivalry. And we would categorize that as competitiveness and disparate values. And again, this isn't we're not going to focus on this part because this is more about the research side of it. But I just wanted to give a little understanding about the data that we use and what we're putting in a database. Anything else needs to be added there, Joe or Alexander?
No, I think you pointed out well, that we've got kind of a mix of data, right? We've got qualitative that you see in quotes, but then, quantitative data from the survey as well, from scales, but also, the way that we measure rivalry, as David described with the 100-point measure.
Right. So far, most of the main source of data collection has been surveys, which we'll look at again in a bit. But that's a great point about the different types, where we've got quantitative and qualitative, and sometimes the quantitative questions have qualitative elements. Sometimes different people will see a different version of each question depending on what we're looking at. So the survey itself is really the complex in the back end. There's a lot of, it's a web-based survey. There's a lot of JavaScript that's going in there. So if you go in and you pick your favorite team, you're going to see your team and your team's logos and pick from the rivals, but you can only pick certain rivals. And it gets complex. The more we're at this, the more complex it gets, which is a major reason why we shifted to using Neo4j, which again I can talk about in a bit. Anything else, Alexander? You think we're in a good spot there?
No, I think we're in a good spot. I think I don't have any questions right now. Yeah, well, it's good, well explained. Yeah.
So one thing that I wanted to do for this session is really focus heavily on the data modeling and the role that Neo4j play and why Neo4j has been so great for us in managing and modeling our data. This was an old version of the relational database that we were using, just a little piece of it, and it was getting unwieldy, to say the least.
Is that a rhetorical question on that slide?
Yeah, I really tried to make it work. I worked hard trying to make it work, and it was when I failed at making it work that I went searching for other answers, and that's when I learned about Neo4j and graph databases and RDFs and triple stores and all these other terms that I was not familiar with around semantic web and these other things that may be familiar to some people in the audience, but to me it was all new a few years ago when I went into this. And once I got into it, I realized that's the level of detail I needed, that atomic data in the Neo4j database and the flexibility that it provides. This is a sketch that I did while I was still trying to make it work in relational database to talk about some of the challenges we're facing. If we're looking at sport data structure, and here's a better view of it. If we're looking for sports, you have all the sports in the world, and I'm just giving an example here. We have men's soccer, but then you've got college and then club soccer. Then there's also national team. And I'm using soccer just to avoid confusion with football. I know football is more common, but for the sake of clarity. So you have the club or pro, and then you have Europe. And within Europe, you have different countries, and they have the league. So for example, you have the Premier League, which is in England, which is in Europe, which is pro soccer. And then you've got the Championship, League One, League Two, and so on. And so thus far, it's not too complicated, and we've been working well with that structure for a while, this idea of having a league, and then you've got teams in a league. So when you are selecting your rival, you get to choose from that drop down that you saw earlier. You choose the other teams in your league, who's going to be the rival. Not too hard. Well, I was talking with a Real Madrid fan one day, and I said, "All right, who's your rival?" And he said, or how would you allocate your rivalry points? And he said, I give, X number of points to Barcelona, X number of points to Atletico, and then probably, 10 points to Manchester United. And when he said that, like, I slumped against the wall where I was standing. Like, I realized my entire data system was blown up because of that, because everything was nested within leagues, and I'd failed to consider that your rival could come from a different league. And that's where this drawing, like, you could be this team down here and your rival is in the Bundesliga over here.
Yeah.
But your rival cannot be a college team or a national team. And so you go up the chain only so far in terms of which teams can be your rival. Here, national teams right here. And then it's inconsistent as well about how these leagues are structured. EPL, they've got the teams nested right under the league. With American college football, you have some conferences, like the ACC has 2 divisions. Otherwise, you've got other conferences where you don't have divisions, or there's not really even a conference at all. And it's always confusing. The more I get into more world sports, the more exceptions to rules that we find. So again, that flexibility is key for us.
Yeah, that makes a lot of sense. I mean, in particular, what you just highlighted about the teams across different nationalities is obviously because of something like a Champions League or the Europa League in football or soccer. You have a more of an international rivalry coming up because the main rival will be most likely somebody in your league at your home country, but then when you play internationally, you will have rivalry with others because oftentimes you will meet them in some kind of final status, quarter or semifinals or something, and then you say, okay, yeah, it's against them again, and we lost again or something maybe, and then you start to probably have some strong feeling against the other teams.
That's right. So then this is, as I was saying, you've got the league with teams nested under it. So this is a little preview of what our data look like in Neo4j, where sometimes we have teams nested directly under a league. Sometimes you have multiple conferences and teams are under that, or conferences and divisions. And that is all possible and easy thanks to the Neo4j structures. And that's what I want to move on to next. Anything else on this in terms of background or why we made this move that either Alexander, you want to ask, or Joe, if you have anything to add?
Well, I think I'll just take a second to clarify like why the structure that you're describing is so important in our context. I mean, you've already talked about, Champions League, and of course we know that there's promotion and relegation as well. Once we started expanding outside of the United States, we realized we needed to account for that. But the point that I want to make is about, why within a league, if there's different conferences or different divisions, why it's important for us to represent that. That's because one of the ingredients to rivalry is frequency of play, or consistency of play, and how often, you play against a particular opponent. And depending on, it varies by league, but a lot of the leagues build their schedule based on teams that are in the same division play more often than teams that are in a different division but in the same league. And so for us, we had to represent, we needed to represent that accurately within the data structure, because it's actually a proxy for one of our key elements for rivalry that we're studying.
Yeah.
Thanks. Yep. Alexander, anything else on the about the why and what brought us here that you had questions on or wanted me to expand on?
Not from me right now, but I wanted to obviously extend the invite to everybody watching live. If you have any questions, any comments, and anything you're interested in us to explore some further, please let us know and type it in chat. So that's always it's always open.
Okay. So let's look at the schema of. Oh, got a question. How would you represent consistency of play? Joe, you want to answer that one?
Yeah, so we would use the actual data for how many times they've played against each other, but we want to capture also the context in which they're playing each other, which we talked about a little bit earlier when Alexander brought up, in soccer, for example, or football, you could play your opponent in league competition, but then you can meet that same opponent in a cup competition or in Champions League, even though you're in the same league. And so when we're trying to capture that as a data point, we're capturing, yes, how many times they've played, but then that's linked to, well, what's the context as well, which is important because we know that some contexts have sort of greater stakes to it than other contests.
Would you, or maybe do you also include the location in there? So let's say there are two teams in a city that, and then maybe they don't necessarily play against each other very often because they are in different leagues. So that means they are just in the same city, and by that they have a local following, which would then mean, okay, the teams in itself don't play as much against each other, but then if you're a citizen of that place, you either like the one or the other team, and then you have a rivalry with the fans of the other team, but you don't see each other as often on the match. It's more like a theoretical rivalry, I guess.
Yeah, you might get that where you have one teams in the same city, so we have like their coordinates as part of the data, and we know we can run it and know how far apart they are. But then, like you were describing, one of those teams gets relegated. Well, now they're not going to play each other as much, but that that spatial proximity that they have, is another element that we know contributes to rivalry, or can contribute to rivalry. It doesn't always, but in a lot of cases it does. So we represent it, with their geo coordinates of their competition field or pitch, right, or arena, whatever sport we're talking about. So where their home grounds.
For Rondos, to your question, I don't know if you mean the graph data science library that's part of Neo4j, those tools, or just graph data science in general. The answer to either is not yet, and we plan to. I've dabbled a little bit with it. Done some work. Both Joe and I have done work with social network analysis, and there's a lot of crossover between the graph data science work and the social network analysis work. So there's a different data set that I'm working with that looks at that a little bit more, but that's something we have barely scratched the surface on, and I know there's a ton of potential for it, and I'm very excited to get to that and use those capabilities of Neo4j because we have all that already in here. So much of the graph data science algorithms and functions and processes, they're all going to be so easy because we already have everything built the right way to transition into using that.
Cool. Yeah, there are lots of possibilities, and I can imagine in this data. I mean, I haven't obviously seen the data itself, but I can imagine that there are some things that would. One thing that comes to mind right now is similarity, right? I mean, you could say, okay, how similar are fans rivals against another team, and is there something that is adopting across maybe even sports types, or how do you say, different sports categories, but also across countries. Let's say in League One, there's this kind of pattern is what the predominant rivalry is, and let's see if there is a similar pattern in another league, and then compare that.
It's funny you mention that. We've looked at that exact thing, and it's fascinating to see how fans construct rivalry differently across different leagues, and that you can see macro level patterns across the league. I didn't expect to see that the way we did. But especially when you look at those antecedents or those rivalry ingredients, and you see how fans feel those are important to shaping the rivalry, you get significant differences with the leagues. For example, the Indian Premier League, which is the world's largest, or one of the best cricket leagues, T20 cricket leagues, those fans put a lot of emphasis on star factors or conspicuous characters. So it's a very star-centric league, whereas something like college football, that is less important than other factors, something like geography. Whereas for Indian Premier League, geography is not that important. And then how the points are distributed. Like in Premier League, fans tend to distribute the points more broadly, whereas in like a college football, the points are more focused toward one or more top heavy towards certain rivals. Across all leagues, the average is about 3 to 4 rivals listed, but the distribution among those varies depending on the league.
Cool. That's very interesting.
So looking at how this is structured, I'm just going to pull up a little bit of notes here so you can see this. So here's an example of a team and a league and season. So you have a team has a squad competes in a season, and a season is part of a league. So let's look at that a little bit more. Down here is an example. So this is the NBA. It is a league. So this is what we would call a league node. So talking about labels, this is the league node, and it has a recurring competition of a season. So the 2019-2020 season is the like an instance. We're talking computer. This is an instance of a league node because that happens during a certain season. And then under that, there's an instance of the Eastern Conference. Underneath that is an instance of the division. And then coming from the other way, you've got the team, the Boston Celtics, and they have a squad that competes in that division. And so you can put it together to figure out which teams are competing in which leagues. And this makes it a little easier to see here, where you have league and then conference, division, season of the conference, season of the division, and then the team has the squad or an instance of the team competing in that.
Yep.
So for the overall, looking at the schema of that. Okay.
Perfect.
So here is our sport div, sport division. That's like a conference or a division or the league itself. So all sport leagues are also sport divisions or all KR leagues. And then you also have sport governing bodies. So like the German Football Association They would have leagues under their Bundesliga, two Bundesliga, Frauen-Bundesliga. That would be under the German, which is also under UEFA, which is under FIFA, which are all sport governing bodies. So that would be that cascading hierarchy. This is the competition. That is the instance. And then you have the teams with their squads, which are involved in those competitions. For college, there's also colleges and universities have athletic departments which have teams, but that's a college-specific section. We don't see that outside of that space. Not totally anyway. We do a little bit. We see the sport org has substructure. And the reason we see that is, think about Real Madrid. You think, okay, Real Madrid is, they play in the La Liga, they play in the Champions League. Well, who are we talking about when we talk about Real Madrid? We have Real Madrid senior men's team, or top level men's team.
Zoom in a little bit in this one?
I can. There we go.
Yeah.
Real Madrid's top level men's team, but then there's also their second level team. Then there's their basketball team. There's their wheelchair basketball team. There's their, I don't know if they have handball or whatever else they have. Those are all part of Real Madrid, the club, which would be a sport organization. And then you have teams under that sport organization.
Yeah. Mm-hmm.
Okay.
Yeah, often teams have, often clubs have more than one team, and then they play in different divisions or different sports. Like
So trying to get, this all makes sense now when we look at it, but trying to get my head around it a few years ago when we were trying to put this all together, really difficult. I ended up taking on Wikidata and just mapping out all the relationships for, this is Ohio State women's basketball, and looking at all the different properties that it had and qualifiers, and okay, you've got conferences and it's competition classes, and using this and trying to figure out how it all fit together in order to think about how we should build our data. So this was really helpful to me in terms of modeling all that. I ended up disagreeing with some of this and building it differently, but that's the beauty of being able to build your own database.
Yeah, because you just said the subdivisions, or not the subdivisions, sorry, the different teams a club might have. I don't know if you looked at that, but that could even be inferred rivalry, right? Because you don't like let's say Real Madrid, you don't like the football club Real Madrid, and they have a handball team or they have a basketball team, and that, because you don't like that, you also technically you don't have nothing against the basketball team of Real Madrid, but because you just really can't stand the football team, you might also prefer another team.
Yeah, I had a friend play on Real Madrid's wheelchair basketball team, and he said even there, so completely different sport, you still saw some of those football rivalries bleeding over.
Yeah.
So this is basic structure, and then competitions happen in venues. Teams have venues, but teams change venues where they their home stadiums, and so these squads also can connect to the venue. And that's, again, flexibility of having all these different relationships. You can have that flexibility and specificity and query against it when you need to. So that's the entity side of it. And then there's the research side of it, which I won't go into too much, but because it's actually more complicated. But we have the survey itself, which has different blocks in the survey, which have different parts of it, or the instrument, sorry, the project, the instrument has different blocks, which have different questions. but those questions relate to ideas. We're studying something, some idea. We happen to be using a web-based survey, but we could get at that idea in different ways. So that idea is this research construct. If we're studying something like Schadenfreude, which is joy at the suffering of others, and that is a concept that we get at using different measures. So those measures are here, and we can get them through all different ways. And that's one way is the using the web-based survey, and that's what all this stuff is. So that's modeling that. This is the survey response, the actual response that a person fills out. So the person, so the survey response, its data source is a real person. So that you can see how if people fill out multiple responses, you can connect them via the person potentially. We can't very well because we don't collect much in the way of personally identifiable information, but it's built to allow that. Where the person was located, what language they took it in, how we recruited them, was through a message board or whatnot. So this is all a different side of the database that only interacts from survey response. They pick their favorite team and their rivals, and that's how it interacts with the part of the database we saw previously, the entity part. And when you put it all together, it looks something like the whiteboard in my office right now, which I drew out. There is something to show here. Look, I can prove it. It's right there. Where this, you have these different layers that interact with each other. Or different, not layers, but sections that interact with each other. There's a lot going on. And I can't imagine, I could do this with a relational database probably, but boy, it would be a mess. And querying it would be a mess too. There's your league and your seasons, and then your teams and their squads. So, the teams have venues. The venues exist in geopolitical locations of countries or cities or what have you. And then those can connect to other data sources, which we'll talk about in a few minutes. And then this is the research side of it, where you have the constructs, items, the survey itself.
Yeah, it's pretty extensive. Yeah.
And for those who are big sport fans, there's this little part right here, which is not really drawn out. That's actually bigger than the rest of the database combined, that little part, because that is the event side. Right now, that's a separate data. I'm in the process of integrating it. But this is an example of a jump shot in basketball, where you have the league, the seasons. This is stuff we saw before, but then you have an athlete, and that athlete has an event. That event is a fadeaway jump shot that the athlete is involved in. And then that event follows a different event where it might be a rebound or whatever it is. So every one of these events has 10 different, at least 10 different people involved in it, because it's 10 people on the court plus coaches, referees, and everything else.
So this is actually the individual performance by player per match?
Correct. So this is where we get a little away from rivalry and into the data analytics side of where, if we're looking at sport-related data, this is an example of how we would model that. And so we do have this all this play-by-play built out like this, where and again, the beauty flexibility of Neo4j, we have season squads that we've been looking at earlier, but we also have game squads where each season squad has a squad that competes in a game, and that squad, players get traded throughout the season and everything else. So you can look at this level if you need to know who's playing in each individual match. And then you can see, all right, if I want to know rebounds, who got rebounds after fadeaway jumpers, you can see the path that you could take to do that, where each event follows another event.
Yeah, that's very interesting, and I guess also very an additional data point. I would think, because if you are the fan of a certain player, you might follow, if they change team, you might follow that team to become your new favorite team, because you're just a fan of the player, not of the team didn't matter so much to you, and then now your rivalry shifts.
Correct. And that's where this ties into the rivalry stuff, because now we can look like, okay, players were on this team, they did this in these games, then they moved. Do we see a change in how people perceive the rivalry afterwards? Or we look at over time, how do teams, if we're looking at the team level, how teams perform, we can look over time and see if that shapes the rivalry. We have all that data and it all ties together.
Mm-hmm.
Okay. All right. So let's look at some query examples and think about what we'd actually do with this.
Yep.
So simple something. Number one, how many respondents are fans of a certain team? Here's the cipher. We would match. We'd have the league to the favorite team. You'd filter for that league, and you could say, then how many survey responses gave a fav-is relationship to that favorite team. So we have the league to the team, league to team, and nice thing with the flexible path, it can go direct or via conferences. And then, we have all our different actual individuals, and who they're all fans of a certain team. And then we get our output that we can use.
Mm-hmm.
So that's very simple example. Who assigns the most rivalry points to a single team? In this example, we can see you've got that favorite team there, and then you have the different survey responses. So again, these are all the individuals who have said that, in this case, Real Salt Lake is their favorite team. We get the rival team is over there, and we see the path through who they say they see as a rival. So these number ones here, this is first rival. I think you could allocate points to 1, 2, 3, 4, 5, 6, however many rivals. This is an example of people who allocated points to their first rival, and then who they see as that rival.
Mm-hmm.
So that's a reminder of how we're using this. And then we get the dyadic output, where we can just aggregate. You sum the rivalry points, which we store on that relationship. So right on here, that's how many rivalry points they allocate. So we can just sum that up and divide to get an average. And we get the average rivalries in the league.
Mm-hmm. Makes sense.
Okay. So something that is, we wanted to talk a lot about the modeling here, because that modeling is where we've spent so much of the time and was so hard, and what Neo4j did so well. But another thing that we can do really well is this database integration with other systems. So we have, our website, we have the database, we have the survey, and then there's external data sources as well. So something like Wikipedia. So let's say we or Wikidata. Let's say we want to know the capacity for different venues. Well, we can just run a query on that. We can get the different venues and their capacities and integrate that into our database, which we can feed to the website or use in the Qualtrics survey. Really what we've used it a lot for are these coordinate locations. So getting the venues, I've done a lot of Wikidata editing where we're putting in the venues in Wikidata and then being able to query that. So every node in or every team node in our database has this Wikidata code for the for that team in Wikidata. And if you're not familiar with Wikidata, it's awesome. For example, here's like the Cleveland Cavaliers Wikidata page, and it's got everything broken out. Okay, it's an instance of a basketball team. Their Central Division, whatever, they were started here. And then the venues, similarly, here's their venue that they play in. And these two are tied to each other. So under the Cleveland, it says home venue is right there, Rocket Mortgage Fieldhouse, which is this Wikidata page here. So it's just like a graph database where one ties to the other. And beauty of Wikidata is at the bottom of these pages, you get identifiers. So if I want to know what the New York Times topic ID is, that's what it is. If I want to know the Twitter username for this team, I've got it right there. And so that can be a great first step toward expanding your data, is going here and being able to pull these and tie in different sources. Which we'll talk a little bit more in a second. So this is an example. If I want to know the start, when did the season start for the NFL? Just run that query. There's the Wikidata query. And this is all the cipher, and just pulls it in, and I get my results of when these different seasons started. If I want average attendance for the Australian Football League, here's the Australian Football League, and there's this website that has the attendance figures. If I wanted to pull that in, I could just load HTML from that source, feed in the data that I have, and get the attendance. So I'm able to tie in those sources. And in the end here, you see where it says this similar to relationship. That similar to relationship also helps us with integrating our data. This is an example of ESPN's database. So ESPN, major sport company in America, they've got their database where they have their own IDs of different things, of IDs for players, games, what have you. So any data set you use that has ESPN data in it, you want to be able to tie it to your own data, or tie it to, let's say, CBS's data, or your own entities that we have. We do that through these similar to relationships. So this is a venue. We have the Chase Center. This exists in our database, this venue, and we know where it is. We have the Wikidata item for it, but it also exists in ESPN's database. So on the similar to relationship, I don't know if you can see there, the similar to relationship has three properties. What the value is for ESPN, they just call it ID in their table. What the ID is, 6270, and then is this an exact or close or what have you kind of match. So this is what we're doing in order to tie our data to other sources. We've got thousands of
okay.
these similar to relationships all over the place in order to do that. Any questions on any of that?
Yeah. If you're just wondering if the ESPN data is I guess not in your database, but if you wanted to query that, or if at some point you could connect to that and then make a connection, then you can say, okay, if I look for the Chase Center and I know the ID, so because it's there, so I can already go and say, okay, the ID for that is this, and then go from, I don't know what else the ESPN data is, probably what team is playing there, and then what like I said, which division are they playing in, or which event took place there, like or some kind of final match or whatever. Yeah, playoff.
So these are all contests. So we have, this contest was Portland at Golden State, and that's right there. That contest happened. That contest was competed by Portland and Golden State.
Okay.
And then we have, so this contest, it also exists on NBA.com's own database. So they call it 221000376. That is their game ID for this contest. So we may never, we will never get, a direct pipeline into the raw data of, it's something that you can query the website. There are other data sources that are out there that they put out data dumps that you might be able to pull from. And so when you see IDs in those data dumps, you can reference that as your primary key there, defaulting to relational database language, primary key in both, this is their primary key that we're able to then merge our data with their data.
Yeah. Okay. Oh, that's cool, and that is it's great that you have it already there, and then you can access it, and it's connected already with your nodes and with your data points. So you have, I mean, that's one of the big challenges. You have your data, others have their data, and how at some point, if you want to collaborate, or if there's some kind of connection in between, then okay, whose ID are we using? Whose ontology are we using? Where is our modeling? You have a different kind of modeling. They have a different kind of modeling the data, and how does it come together? And because you already have the values there, it makes it much easier to connect.
Mm-hmm. Yeah, and it's been great also with the countries. You have we have all our countries and nodes for those, but the FIFA has its own codes.
Mm.
The UN has its own codes. The International Standard Organization has its own codes. And so each country or geopolitical node that we have has all these similar to relationships. For example, the United Nations does not consider England a country, but FIFA does. Because for the United Nations, it's the United Kingdom. So we can have an England node that is part of the United Kingdom, but also connects directly to FIFA. And actually, it goes England to the FA, the FA to FIFA. But you make that connection with those similar to relationships. So we know what England, how FIFA abbreviates England, for example. If we get a FIFA data set, we can tie into that.
Yeah. Very cool.
Also thinking about integrations, we have on our website, we have a search. So if you search for Cleveland, you get Cavaliers, Browns, Guardians. These are, you can just search here. There we go. And it brings up the search. Well, what is powering that? Well, what's happening is the search is going out and in our database. So if we Cleveland, it goes through and eventually returns, runs this query and returns information that feeds the database. So on our, I like looking at the data this way a little better. Some people are going to write Cleveland. Some people are going to write CLE. Some are going to write Cavs. Some, might write, Browns, whatever they're looking for. So we want to have all these different terms, and we can load those on nodes. And then with the query, it will go up the chain, however far we tell it to go, in order to find those nodes. For example, if we did Michigan, store that, and Michigan. So it pulls back everything Michigan related. But Michigan is a university, or Michigan's a team that's in an athletic department that's in a university, and the cipher goes up that chain to find that. So this is the path for pro, where you've got a parent organization that has a substructure of a team. A college university has a parent organization, which is the athletic department, that has a substructure of a team. And so this type of structure, and on each of these nodes, we are able to store terminology that in different fields. So here are all the fields that got checked: term alt names, term abbreviations, term what we feed to Qualtrics, what we feed to the website, what the long name is, the mascot, any other terms that are used. And so it checks all of those and returns here, and that's what the search terms can go against.
Okay, yeah, that's very cool and very, very powerful, because then you have all these like you said, I mean, you could look for a mascot, you could look for a location, you could look for the actual team name, and you would find them.
So that's what the integration allows us to do, is we put that in one place and it feeds everywhere. I know we're short on time. I just want to show a couple more things that are fun. This is just the fun stuff now. We want to know what the correlation is between how far away teams are and the rivalry points. Well, thanks to having all our data here, we can do this, where we just sum up, we get our teams, we get our venues, we know the venues. Every venue we've got latitude and longitude for, and we've got the distance calculation here, which is actually now point dot distance, if we want to be precise. And we get the kilometers between teams. And so then we can just run a quick Pearson correlation and see how important is geography to these different leagues. Back to our earlier conversation, you can see not very important to IPL, pretty important to MLS. But that's that key feature right there. While writing this just for fun, I stumbled on this, accidentally wrote a query that found the teams that are closest to me. This isn't where I just use it as an example. Where you can put in a location, and using the spatial tools within the APOC spatial procedure, you can get the latitude and longitude for that location, and then figure out what's within X number of kilometers. So I did 150 kilometer radius. And so these are the different teams that are within, how many kilometers to this location. So if you're traveling for work, you want to find a good rivalry game, you can throw it in here and find which teams are going to be playing near you, for example. Again, fun stuff, not the, haven't found a great application of that yet, but with the distance, one thing we're doing is we're looking at carbon impact of teams traveling. So we know their schedules, we know where they're playing. We can calculate the mileage child, or what effect does mileage have, or kilometerage, on performance, because we have those distances, we have the performance, they're all tied together. We can answer that thanks to having the database.
Yeah, that's very interesting. I mean, there is always this home versus away advantage which you have, but if you have not a very far distance, and I mean still you probably have an advantage because of your fan base, but then if you need to travel further, then you are maybe more fatigued from the travel, and then that comes into play as well. So yeah.
Yep. And yeah, and if you get data on fans, let's say a colleague of mine did a survey on WNBA fans, I can integrate that data with our data. We know what WNBA rivals are. We know where those fans are because in his data they collected it with locations, and we can combine that information.
Mm-hmm. Yeah, that's super cool, and yeah, very exciting. So what's next, or what's the future for Know Rivalry?
Well, the big one is there we go. Big one is further expanding into leagues. Right now on the website, we have 7 leagues, but we've been collecting data from over 60 and are going to be doing that in more earnestness over the next couple weeks and months. So expanding that, branching out into rivalries outside of sport. So could be
Okay.
like
Yes.
rival, between brands,
Mm-hmm.
between politics,
Mm-hmm.
political or geopolitical identifications, even rivalries among people on the same work group, like sales team, and how that
Oh,
those
yes. Yeah.
interpersonal rivalries can
Yeah.
play out. Because while we're studying sports and sports are fun and everything else, what we really care about are these bigger issues about how people identify with groups and form their identities, and how that affects their interaction with others. So
Oh yeah,
that's
I can imagine that's another interesting point. Yeah. Yeah, cool. That sounds exciting. So I guess we need to do a follow up at some point.
yeah. Well, we will. We've been quiet lately with stuff, partly because of building out the database, spending so much effort on getting this database right so we can build on it.
Mm-hmm.
But we're going to be more active in the next year or so in terms of releasing the data and getting new data out there, and understanding that. So following us on Twitter, there's also at Know Rivalry on Twitter is where we put out some stuff, and Joe's been great about integrating his students with this project as well, and using this as a way to teach, as you said, teach his class, and he gets them involved, especially with the Twitter side of it. But that is a great way to follow along. I mean, you could look in academic journals and read long, publications that are of varying levels of interest, but Twitter's probably a better source for finding quick info.
Okay. I just posted that in chat. If anybody is watching this and thinks they want to participate, he or she wants to participate. So what is the best way? Is it go to the website and take the survey, or what would be? Yeah.
Yep. There's if you're looking on the website, let me share that again. If you're looking on the website, there's a box in the upper right that says take the survey. That will bring you to the Rivalry Research page, where you can pick from different leagues. This is, again, going to look different later on. But this is, again, all being fed by that backend database that's driving this. But you can pick your league and pick your team, and then go through the survey. That way, we'd love to hear your thoughts, and who you see as rivals.
Super, very cool. Yeah. Thank you very much to you both, David and Joe. Joe, anything to add before we wrap up? Because David talked a lot now, so I don't
Yeah,
want to
sorry
cut you
about
off.
that.
No,
He's used to me getting excited. Like, I try to
He's the
shoehorn this
architect,
into other meetings. Like Joe's sitting there, he's like, I know he's going to bring up the database. I know it. So, sorry, Joe.
That's fine.
No, I don't have anything to add. That's yeah. I mean, it has. We started in college football, and then we did our domestic leagues here in the United States, still with the relational database. But it's made a huge difference as we decided, okay, we're ready to expand and go across the world with this in terms of data collection, and that was the point where we made the transition. And as you can tell from David explaining it, he's the one that made it happen. So yeah, it's been a great transition for us.
Cool. That's good to hear. Yeah. Thank you very much for presenting and for showing it. Particularly the demo part was, I think, very interesting. It's a cool application. I hope it goes paces, and I hope see more of this. I think it's when you want to expand into brands and other stuff, politics. I could imagine this could be a very, very, very interesting project going beyond the world of sports. So because there's much. I mean, you showed Coca-Cola and Pepsi. I mean, Xbox and PlayStation. I don't know, Nike and Adidas. I mean, it goes. It's just any brand you can pick, Windows and Mac. So it is really very, very. There's always like a dual. At least.
And it's really about identity. We have colleagues we work with that look at Israel, Palestine. That's above our understandings, but the concepts, the identity ideas are similar, and we can learn from each other on that.
Absolutely. So yeah, thank you very much to you both again for taking the time and for showing it. Thank you for watching, everybody. Hope this was interesting. I'll wish you all a good rest of your week. Take care, everybody, and see you soon.
Thank you, Alexander.